Hello viewers, my name is Raj and welcome to my YouTube channel. So this is another video in the complete placement preparation series, and today we'll solve this particular problem from Leetcode, which is numbered as 88 and the name is merge sorted array. So we'll look into the problem and then we'll look about the solutions, and we'll try to code this out and submit on Leetcode. So let's go and watch what's the problem. Yeah, so this is first of all, this is termed as an easy problem. So we'll be given two sorted arrays. So let us say nums1 and nums2. So these are individually sorted. So if I take an example, let's see. Yeah, so let's say we have two set sorted arrays, 1, 3, 5 and 2, 4, 6, 9. So these are individually sorted arrays, and we want to merge them to get a complete sorted array. Yeah, so basically the task is to merge them and produce an array which has total number of elements, which is the combination of both. But at the end of the program, the merged array should be sorted as well. And so here the trick is Leetcode has done some pre-processing and post-processing for us. So Leetcode, what the question says is the nums1 will contain additional space so that it can accommodate nums the second array as well. So basically whenever we are merging, we have to either create a new array or adjust in one of the arrays. So in this case, we have to adjust all the elements in nums1. So nums1 will contain extra space at the end, and we have to we have to combine nums1 and nums2 in a way so that we can accommodate that particular space. So the size will be m plus n, where m is the size of first array and n is the size of second array. So basically this is the one such test case. So we have the nums1 as 1, 2, 3. This 0, 0, 0 is nothing but the additional space. So, and we can confirm that by using the m parameter. So m is nothing but the size of the first array, which is 3. So after 3, whatever the elements we see are just nothing but additional spaces for the final array. Similarly, we have nums2 which is 2, 5, 6, and it is space, its particular number of elements is 3, which is very evident. So at the end, we should have an array something like this, which is 1, 2, 2, 3, 5, 6. So if we see nums1 and nums2 elements, we can see there is 1, 1, 2 2s, 1, 3, 1, 5, and 1, 6. So if you see in the final array, we have the same. Similarly, there is also a trivial test case, which is, I think, the base case. So we have to keep in mind that this test case should also be passed. So let's go first towards the logic and solution, then we'll at the end we will code. So let's say I have this particular two arrays in the input. So and additionally we have this two particular 3, 1, 2, 3, 4. They have this additional space to accommodate the second array's element. So if we see the traditional approach or our conventional thinking, what we think is, let's say I append all these arrays into in a single array. Let's say I have 1, 2, 4, 2, 4, 6, 9. So the traditional wisdom says that I'll have all this array, all these numbers in a single array, and then I will sort it. So which will basically give the output. But if I see in the computationally how expensive it is, basically if I take the best sorting algorithm, it will take around n log n time, right? So which is the computational complexity of this, or time complexity of this particular code. So in this case, the n log n time is the merge sort algorithms, or the best time any sorting algorithm can get. Similarly, if you use merge sort, it will have another overhead of an order of n extra space, right? So the space complexity will be order of n. So this is okay, like, yeah, fine. If in a normal situation this work, but if I take a lot of elements, let's say 1 million elements, and second array we have 2 million elements, then this might be a very computationally expensive task. So we have to somehow reduce the particular time complexity. So what the solution, optimal solution, says is, I will take the first two, let me first clear this particular thing. So yeah, so what the optimal solution says is, let's if we see in this particular thing, both the arrays are sorted. So let's say I start with the first elements of both the arrays, and I compare and I try to make it sorted. Let's say I take first element of the first array, which is 1 and 2. I will compare them. So which is smaller? 1 is smaller. So I will keep 1, and I will pass this increment, or I will go to the second element of the, like, I have taken for 1, right? So I have to move towards ahead in the second in the processed list, and since the 2 is not processed yet, I have to keep comparing with 2 again and again. Now I will take 3. But this approach is fine, but in this case we have, like, if I see, I have to shift all the elements because I am editing this particular array, this first array, right? So I have to shift all the elements in case of any swapping. So in this case, if I see, if I compare 3 and 2, what I have to do is I have to keep 2 here, and I have to I have to shift all the elements so that I can accommodate 3. So that in this case, this approach might not work, and it will be again computationally expensive. If I have to make a new array, then it's good, because in new array all these places will blank, and I'm free to use start with the beginning or the end part. So in this case, the starting from the beginning will also not work. So let's go towards this the other thing. Let's start with the at the end of the array. So if I take the second approach, or I will start with the end, I will have to first compare 5 and 9. So 5 is greater than 9 is greater than 5. So I will take 9, and I will keep 9 at the end. So if I see in this list, I will have 9 at the end. Similarly, I will decrement the pointer of from 9 to 6. So I will now process 6. So I will now process 5 and 6. Since 6 is greater than 5, I will keep 6, and I will process 5 again. And I will move towards 4. So now I will compare 5 and 4. Since 5 is greater than 4, I have to take 5, and similarly I will process 3, and I will keep 4 as it is. Now I will process 3, 4. Since 4 is greater than 3, I will go towards, I will take 4, and I will keep 3. Similarly, if you keep on doing it again and again and again, I will get the sorted array, merged sorted array. So if I say in this particular case, the maximum time complexity I get is order of n, right? By order of n, I means the elements, both the elements. So in worst case, I have to compare like all the elements one by one. So it will again be at max m plus n only, where m is the size of the first array and n is the size of the second array. So this is the worst time complexity, and space complexity there is no issue, because I am replacing it in this in the input array only. So there is no problem of space complexity. So this seems a very good logic or optimal logic to follow. Let's try to code this thing. So I have m and n, which is the sizes of the array. So I have to first of all take 3 pointers. So first pointer is m minus 1, which is the last element of the first array. I will take j equals to n minus 1, which is the last pointer of the second array. And then I will take k. K is nothing but the last pointer of the, or the last index of the merged array, which is nothing but m plus n minus 1, right? So if I take a small example, I have 3 elements in the first array, I have the 2 elements in the second array, then I have total 5 number of elements. But if I see in a merged array, the last index I have will be 4, because in an array of 5 elements, their indexes start from 0 and end at 4, right? So I have to subtract minus 1 from all these numbers. Okay, so now the logic begins. So I will have a while loop. I will check if I is greater than or equal to 0, and if j is greater than or equal to 0 or not. So basically I am checking if I have gone too far or not. So if I start from the end, I have to somehow stop at the beginning. So it will indicate that, okay, this array is fully processed and there is no required to process it further again, because the elements will be over and will be traversing it in a negative index, which is going to be a infinite loop, which is not we want. So now I have two pointers which are pointing at the end of the individual arrays. What I will do is I will simply compare them. If nums of one I, which is the I pointer is nothing but for the first list and j pointer is for the second list. So if I check if it is greater than or equal to so there is always a trade-off. So you can either take greater than equal to not. If you don't take equal to, then it will be again processed in the second iteration. So there is no problem. It is always a trade-off that one do. So I will check if the first array was greater than 2 or not. So if it is the case, then what I will do is I will have nums of 1k, which is I will keep this particular element at the end, and I will decrement the k pointer. Similarly, I will also decrement the ith pointer because I have processed that particular element and I have kept the sorted item at the end of the array. So I have to move towards the left for both the arrays. So in this case, both the arrays are same, but I have to move the pointers towards the left so that I can further go into the algorithm. So if this is not the case, so basically if the first last element of the first array is not the bigger one, the second array is bigger, the last element of the second array is bigger, then I have to do the same process, but I have to change the pointers. Or the in this case, I have to change from nums1 to nums2, and here I will be having j pointer because j pointer is for second array. Similarly, I have to change the j part here. So this seems fine, and but there will be a case or a case in which there will be all the elements of the first array will be processed, but there will be some elements in the second array which will be yet to process. So we have to take that take that into account. So what case I am suggesting is, let's say you have an array something like 5, 6, 7, 8, right? And you have the second array is 1, 2, 3. So in this case, all the sorted array will be 5, 6, 5, 7, 6, 8, 7, 6, 5, and then 2, 3, 2, 1, right? So if I see in that while loop, what I will have is I will achieve this particular thing, but I won't be achieving this particular thing because the while loop will terminate as soon as I reach this particular I to 0. As soon as I reach I equals to 0, and if I try to whenever I am processing this particular file, what will happen is at the end of that particular iteration, my I value will be -1, right? And then loop will break. So and the work will be incomplete. So to do that particular task, I have to also additionally check if this particular array is processed or not. So for that, I have to check if the value of j is greater than 0 or not. So I will basically check if value of I is greater than or equals to 0. If this is the case, then I have to additionally manually add them to the sorted array. Nums of j, and then I have to decrement both the pointers and keep on going it. And this is all the logic for I have. If the value of j is not greater than 0, then basically this program will add at this particular stage only. But if the second array is not processed fully, then we have to this loop will be executed as. So this is an additional thing, and don't we have to not return anything. Let's try to run this on the test cases. This is taking some time. Yeah, so the code is running. Let's take another test case. I will take the trivial one. So 1, 1. I will give the empty array as input. Let's try to run this on this particular trivial example. So yeah, so the trivial exam on trivial test case, it is also running fine. Let's try to submit this thing. So yeah, the runtime is 36 milliseconds for Python. So for Python, it is fine. We are better than 76% of the online submissions, and we are less than almost 100% of the in terms of space. So this particular logic works verified. So that's all in this video, and keep liking, keep sharing, keep commenting on this channel. And if you have any queries, doubts, please ask in the comment section on my social media or the Discord channel. So all the links are given below. So take care of your health and have a nice day.